Ma'am, please start with the introduction.
Yes. Very good morning to all the dignitaries and participants. Today, on this last day of our 21-day national training program, it is my privilege to welcome the renowned statistician, Dr. Ram Verma, Principal Scientist, ICAR IVRI, Bareilly, Uttar Pradesh. Before that, I would like to give a brief introduction about Sir. Sir has completed his degree from Himachal Pradesh University, Shimla in 1995 and MSc in Agriculture Statistics in 1998 from Dr. Y.S. Parmar University of Horticulture and Forestry, now in Solan, Himachal Pradesh. Sir obtained his PhD in Statistics in year 2005 from Dr. B.R. Ambedkar University, Agra, Uttar Pradesh. Sir joined ARS in March 2003 and he joined IVRI as senior scientist in December 2009. Presently, Sir is working as principal scientist at ICR IVRI with effect from December 2015. Regarding achievements, Sir has contributed significantly in the field of sampling theory, applied statistics, and biostatistics. Sir has guided 4 PhD and 10 MVSc students in the discipline of biostatistics at IVRI. He has also supervised more than 113 students, including 71 MVSc and 42 PhD of other disciplines as a member of Student Advisory Committee. Regarding recognitions and publications, Sir has already published 212 research papers in various national and international peer-reviewed journals, and Sir has been awarded with Best Teacher Award for the year 2014-15 by ICAR IVRI Bareilly on 5th November 2016. Sir has also been awarded with the prestigious Bharat Ratna Dr. C. Subramanian Award for Outstanding Teachers 2018 by Indian Council of Agricultural Research, New Delhi on 16th July 2019. He is the referee of several national and international journals and member of editorial board of several reputed national and international journals. With this very brief introduction, I warmly welcome you, sir, to this platform to enlighten our participants with the most awaited lecture on biostatistics. Please, sir.
Thanks, Devi, for your introduction. I am thankful to the organizer for giving me the opportunity to uh, deliver a lecture in this training program. Topic of my lecture is the basic statistical method for analysis of experiment data. The statistical tools they are very essential for analysis of the numerical data in the biological and the other sciences. So before starting the other parts of the lecture, let's start with some basic concept. We know what is the data. Data is a collection of facts. This is known as the data. So data can be either qualitative or quantitative. And variable, this is any quantity that can have a number of variables. Both vary with a property that can take different values. Actually, it will in data. So this is that the quantity is very. The quantitative variables that we assume values in terms of the magnitude. For example, we have weight, height, age, distance, etc. These are all the quantitative variables. So we have variables. These are attributes only. These variables can be categorized. That is gender, nationality, socio-economic status, and academic quality, etc. Then we have discrete variable. Discrete variable is the variable which takes finite or countable finite distinct values. And for example, number of students in the class is a discrete variable. Actually, then we have continuous variable, the variable which assumes infinite number of values with a certain range. In this case, we have example is that length, height, weight, and volume. These are the continuous variables. So then we have distribution. This arrangement of a set of numbers classified according to some properties or attributes such as age, height, weight, etc. Then we have population. Population is the aggregate of object under study. In general, it is assumed that population is assumed to be finite, but uh, when we are dealing with some such work, then we assume that by population is finite. Sample, this is part of population, or your this is a group of units which are selected from the larger geographic population. Sample, this is the subset of the population. Then we have estimate. Estimate is the value of the any unknown quantity based on the observed data. Actually, in this case, if we find the an estimate is the particular value of the estimate that is obtained from the particular sample data. And now in this case, estimate, so we want to find the sample mean, that's the particular value that will be the estimate. Then estimate is the process by which we get information about the unknown population parameter by using the information contained in the sample. Actually, whatever we draw a sample and from sample we get some information. This process is known as the estimation. Then we have primary data. Primary data, this is the any data which collected by the university through surveys, personal observation, interview, etc. or questionnaire. This is on the primary data. Then we have secondary data. Secondary data, this is our data which is collected by university from the published sources, that is either from the journals, newspaper, magazines, boards, theses, report, and medical etc. Then we come to the means of central tendency. Actually, what happens that in all the institutions there always a point around which most of the observation like fluctuate. This tendency of data to cluster about any point in the central tendency. Actually, we have different types of we have two types of averages. One is mathematical average, other is the position average. Actually, mathematical average, these depend upon their numerical calculation. There we have arithmetic mean, geometric mean, and harmonic mean. In case of position average, these depend upon the position of the data. Then in this case, we have median, mode, partition values such as quartile, decile, and percentile. Actually, arithmetic mean is a more widely used mathematical average, and median is the value which divide the data into equal parts, and mode, this is a value which occur maximum number of times in the frequency distribution. Then we have quartile. Quartile means that when we divide data into 4 equal parts, these are known quartile. This one in the decile, we divide data into 10 equal parts. In this percentile, data divided into 100 equal parts. We know this, all you know that arithmetic is the nothing. This is just sum of observation divided by the number of observations. Then when this data group, then this is the then we have multiply frequency with the x1 plus like, then we take the sum of all fi xi and divide by the total. Frequency. In case of weighted frequency, that will be weight. Then sort of this you know that this is not see. Then we have example. Mean in case we have 10 numbers, then we take the sum of all values. The weight divided by 10. This one. In case of this is your group data. 0 is repeated two times, 1 is 3 times, and then actually you can say that 1 marks obtained by 3 students, 2 is 4 like that. So in this case, we multiply 0 with 2, 1 with 3, 1 with it, and take the sum, then divide total. The total frequency is 28. So we get some value. So then we have geometric mean. Geometric means we take the product of all the values in case of individual city and raise to the power 1 by n is the number of observation. Similarly, when we have frequency issue, then in this case we find that geometric mean. Then x1 raised to power frequency f1, x2 raised by f2 like that, and total is raised to power 1 by capital N, where capital in the total of all the frequency. Then we can take the logarithm and we can calculate the geometric mean. Then in case of harmonic mean, actually what happened, this is harmonic mean, this is nothing, that's the reciprocal of the order of the value. So that this is 1 by the all reciprocal values. Then median, we know that this is the value we divide data into 2 equal parts. So we have the different method of calculation for mean. When the data is ungrouped data, in this case, what we do, we find n plus 1 by 2th value. When n is odd, but we have n is 7, so 7 plus 1 by 2 is this 4th value will be the median. But when n is even, in that case, then n by 2 term plus n by 2 plus 1 term will be this one. So in the data group, then in case if we find this value, and we can obtain the value of the median. Similarly, when in case of continuous series, this is median obtained by L. This is the lower value of the class with the median lies, and by 2 value minus this is the cumulative frequency. C is the cumulative frequency of the median class, and H is the width of class, and F is the frequency of the median class. So in this case, we have median and group data. We have this data. So in this case, what we do? First, we will arrange the data in the ascending order. Then we will find the median value. Then similarly, when we have here in case of 1, 2, 3, 4, 5, 6, 6 value, first we have arranged in data, and because in this case 1, 2, 3, 4, 5, 6, 6 value. So this is third, and this will be this will be the third and fourth. Mean of third or fourth will be the median value. Then in case of mode is that value which occurs maximum number of times in the frequency distribution. So in case of marketing, some items are prepared based on the mode. So shoes, clothes, they are all prepared based on the mode value. So these are the methods. Then in case of simple series means when we check that which item is within maximum number of times, so then we can find that will the mode. And in case of control series, this is the formula for calculating mode. Then in case of asymmetrical distribution, the distribution out of symmetrical, in this case mode can be obtained by the 3 median minus 2 mean. Then we come to the dispersion. Dispersion means we see that there is always scatteredness in the data set. This scatteredness in the data, this is known as the dispersion. Dispersion, there are various measures of dispersion: range, quarter deviation, mean deviation, variance, standard deviation, and coefficient deviation. These are all the measures of dispersion. Actually, among all the measures of dispersion, range is a crude measure of dispersion. So this the range will give us a rough idea about that how much scatteredness is there in the data set. And among all the measures of dispersion, standard deviation is the best measure. It is most widely used measure of dispersion. Then actually we have two types of measure of dispersion. First is absolute measure of dispersion, other is the relative measure of dispersion. Actually, absolute means the range, quarter deviation, percentile deviation, then mean deviation, variance. These are all the absolute measure of dispersion. These are relative. Relative means there we have some ratio: coefficient of variation, coefficient of mean deviation, coefficient of range, coefficient of quartile deviation. So then we know that range is a difference between the maximum value minus the smallest value. Then we have quartile. We know the quartile is there in this case data is divided into 4 equal parts. So quartile, this is the quartile range. This is the quartile is Q3 minus Q. This is the quartile deviation. Then we say is interquartile range. This is divided by 2. This is the quartile range. The Q3 minus Q1 divided by 2. So now then we have mean deviation. Actually, mean deviation. Actually, in this case, we take the difference between the object that is the value minus the mean values. Then this is the absolute value, and we multiply with frequency and divide by the total number of observation. Then we have mean square deviation of the object from the actually this what happened that this is the xi minus this is in case of population we have xi with this is population mean square of the division divided by n. Actually in this case we take the sum of square of the deviation and then we take the square root. In case number this is sum of square deviation from earthly mean, this is population mean, square divided by n and so on. Actually, why you can say that it is capital N here. So minus 1 there. Actually, the main reason behind that this is unbiased estimate of the population standard deviation. The square root of the in general we know that standard deviation is the square root of the variance. Then there are the various formula for frequency distribution how to calculate find the standard deviation. Then we have the relative deviation. In case we have coefficient variation, coefficient of mean deviation, coefficient range, and coefficient of quartile deviation. We know the coefficient of variation. This is the standard deviation divided by mean into 100. Now this is expressed in the percentage. The main advantage this is very widely used measure of dispersion, because in this case when we have the different units, then we can also compare that which series is variable. Now for example here we have a height. In this case mean is 40 inch and the standard deviation is 5 inch. Now here mean is 10 kg weight and 2 kg is the standard deviation. Now you can see here that the uh, this unit of height is in inch and unit of weight is k. So now we can also check here that which series more variable. So now in this case we find a coefficient variation, and then we find this is 25.2 and this is now in this case we see that in case of weight, 20 coefficient variation is 20, so 20% means it is 12.15%. It means that there is a more variability in case of the weight as compared to the height. Then we have coefficient mean deviation. This is where we take the ratio of mean deviation divided by mean into 100. Then coefficient range in this case, the largest value minus smallest value divided by the largest sum of largest into it is expressed in the percentage. Then we have coefficient of quartile division. We take the distance between third quartile and first quartile and divide by the sum Q3 plus Q1 and multiply by the 100. So this is expressed in the percentage. So then we come to the skewness. What happened that in case of data, there is not data is not always symmetric. So the skewness measures that this asymmetry is there. Then the skewness, this is the lack of symmetry. It shows the degree of the symmetry or departure from the symmetry of the distribution. It also indicates the direction of the distribution. Also, actually, what happened when the longer tail is in the distribution toward the right side, it is set to positive skewed. When it is towards the left side, we set it is negatively skewed. We can see here when this is longer tail is toward the left side, so it is we say that is negatively skewed, and in case of when it is towards the right side, it is positive. Now when the tail, both the tail are in they are symmetrical. So in this case, neither it is toward left, neither is toward left. It has the same equal distribution, so it is known as the symmetrical. So now we see what happened. There's in this case our mean minus what we say that when mean minus 40 is less than this one, so we say this is a negatively skewed distribution. Now measure of skewed symmetry, actually in the case these are not then the measure is obtained by the Pearson coefficient of skewness. In this case what we do, we find the mean minus what divided by standard deviation. In this case what happened that when mean is greater than more, then we say that it is positively skewed. When mean and mode are same, then we say it is symmetric, and when mean is less than more, then we say it is negatively skewed. Now you can see all the things, but I clearly mean good, then this positively skewed. Mean is the next one. When mean and mode they are same, they are lying the same line, then we say that it is there is no skewness, so skewness is 0. So this is other measure of skewness. Now in this case, what happened is we can calculate is the mean minus median divided by standard deviation. So when S is this less than 0, this is negative skewed. In the case 0 is when both are same, the S is 0 and this is positively skewed. So now we have other measure also measure of skewness also. Then we have this is coefficient. I have told you this is the same formula from derived from this one. Now here the carrier coefficient skewness, this is based on the desired value. The positive coefficient based on the quartile value, and we have the moments based on the coefficient of skewness. Now this is center movement. In case what happened that center movements means that this is in case of physics we know that force multiplied by distance, this is known the movement. So in case of similar to here in this one, we also find movement in case of statistics also. When F is F into multiplying x minus x bar. So now this is when we take the third power, this is mu 3, this is mu. Actually mu 3 this is used for obtaining the value of skewness, and mu 4 this is used for obtaining the value of kurtosis, and mu 2 this is the for variance, and mu 1 this is always 0. Then we have the kurtosis. The kurtosis means this is the flatness of the curve. Actually when there is no flatness in the curve, then this is said to be mesopartic or symmetric. When the curve is highly peaked, it is said to be elliptopartic. When it is flat, then we say it is a platic pattern. Then in this case, Pearson coefficient and Fisher coefficient, they are used for finding the value of skewness and kurtosis. Now here you say here, now this value, the curve is, this is normal curve. Now this is your flat, this is platypartic. Now this is when this is highly peaked, this is said to be elliptopartic. Then I have this is that is highly peaked as compared to normal curve. This is elliptopartic. Then this is flat, is platypartic, and when this is Smithy, this is the mesocardic. So now in this case, the measure is that when beta 2 minus 3 greater than 0, this is leptocardic. When beta 2 is less than this is bradycardic. When beta 2 is equal to 3, then the this is said to be mesocardic. So similar same thing here. Then we have correlation. Actually, what happened? Correlation coefficient. This is the measure of degree of association between the two variables. Actually, we sometimes want to find whether there is some relationship between the two variables. Now that for that obtain that value, we find the correlation coefficient. So now Pearson correlation coefficient is used to find the association between the two variables, and this is independent of change of origin, and this is lies between one. Actually, in this case, so the when value is 1 plus 1, that we say that is a perfect positive correlation. And when this is value is minus 1, we say that this is a perfect negative correlation. Actually, positive correlation means that when x is also increase, y also increase, when x increase, y also increase. When negative correlation means then when x is decreasing, y will increase, and if y is decreasing, then x will increase. So, but when we have a rank data, then we spherical rank correlation coefficient is used. Now here this is, if the value close to 0, then we say there is no linear association between the two variables. When it is greater than 0, then this we put a positive correlation. When it is less than 0, we say it is negative correlation, and it actually normally it lies between plus 1 and minus 1. Then we find out what is the regression. Actually, correlation gives us the that whether there is some association between the two variables or not, then it also does not give us the point that how the variables are related to each other. Then the regression this gives the average relation between the dependent and the set of individuals. Actually, this will give us an idea that how the variables are related to each other, whether they are related to each other by linear relationship with linear or like that. The relation between dependent variable and the set of is known as the simple regression. So actually, when we have one dependent variable and one independent, then we say the simple regression. But when we have one dependent variable and we have many independent variables, then we say the multiple correlation. The method is very to fit the regression, and that goodness of fit is seen by. So we can fit this error. If we have multiple regression, then we have different x1, x2, x3. Actually, why dependent variable depend upon various values. So this is the multiple regression. Then we come to the test of signal. Actually, the first test of signal was by the in 1908. Actually, he was working in something, and his company was not allowing him to publish his work under his own name. So he published his search under his name, student. So actually, this test he used to test the population mean. Actually, the main assumption of this test are the parent population from sample run is normal. Sample objects are independent and population variation is unknown and sample size is small. Actually, these are the main assumptions that the population from which this sample is run, this is coming from the normal distribution. In this case, we say that sample objects these are independent and population variation is not known to us. Actually, when population variation is not known to us, then we can obtain the value from the sample. Then in this case, what happens? This is the small sample test when n is less than 30. So now in this case, when sample size is small, then the distribution variable is not normal. In this case, it follows a distribution known as T distribution. Now in this case, null hypothesis these are actually mu is equal to mu naught. This h naught is mu is equal to it means that we say that a sample has been drawn from the population in which the population value is mu naught. Alternative is that mu is not equal to mu. Actually, what suppose we are drawing a sample of cows from herd, and we want to see that whether the milk yield is average milk yield is 6 liters in a particular herd or not, and then we say mu is equal to 6, and alternatively will be mu is not equal to 6. Actually, mu 6 means that the sample has been drawn from the population which the average milk yield is 6 liters, and alternatively mu is not equal to 6. Then actually in this case, actually population value is given to us x1. We try a sample, and based from the sample we find this x1. This is the sample. Then we have the sample standard deviation. Now this value follows the t ratio bit and minus distribution. Actually, what happened there? We will calculate this value, t value, and when the t value is calculated, then we have to see the in case of T distribution, we see the value at n minus 1 degree of freedom. If T calculated value is more than the T tabulatory value, then in that case we reject the null hypothesis and conclude that mu is mu is not equal to mu 0. But if T calculated is less than the tabulatory value, then we accept the null hypothesis and conclude that the sample has been drawn from the population in which the population mean value is mu naught. Now we this is two-dimensional sample. Like, in this case, we want to test whether the two samples has been drawn from the two population or they are drawn from the same population. So now in this case, in this analysis we say mu is equal to mu 2, or in this case we say that the population mean of the two groups are same, and after that they are not the same. So now in this case, T value, this is x1 minus mu1, mu minus mu2. Now in this, what happened under null hypothesis becomes 0. This is the standard, joint standard division, and n1 is the number of objects in the first set, and n2 is the number of objects in the second set. Now in this case, this is the combined standard deviation. How to obtain? We know that S1 square. This is the sample standard deviation of first sample. This is the standard deviation of the second sample. Now in this case, degree of freedom will be n1 plus n2 minus 2. So now in this case, we have to see the T value at n1 plus n2 minus 2 degree of freedom at either 5% level of significance or either 1% level of significance. Then in this case, what happened that if this is the T calculated, if T calculated is more than the T tablet value at alpha level significance, then we reject the null hypothesis and then accept the alternative. In this case, we say that the sample has been drawn from the two different populations. Otherwise, if this T value is less than the tabulative value at n1 plus n2 minus 2 degree of freedom and at alpha level significance, then we accept the logical conclude that the two samples has been drawn from the same population, or you can say that the two samples have been drawn from population, or you can say the population mean of the two samples are same, which means that they are coming from the same population. Now, in case of paired T, actually this test is usually applied. This is also known as the mesh paired test. Actually, this is applied in case of when we take the observation from the same individuals. So we have 10 animals, and then we are trying some from blood sample and noting down some parameter. Then we are giving the medicine to 10 animals. Then after certain days, we are noting down the film. We are taking the same blood sample from those. So in that case, so this is the observation on the same individual. So this is now in this case, d bar is 0 means that there is no difference in the mean before the treatment and after the treatment. You can say that difference between the before treatment minus after treatment is 0. This is the same, and in this we can find this difference, and this is degree of freedom n minus 1 degree of freedom. Now similarly in this case, what happens that if T calculated more than the T tablet value, then we reject the null hypothesis and accept the alternative. In this case, we say that there is a effect of treatment. When this T calculated is less than the tablet value, then we accept this one. It means that there is no effect of treatment, or before treatment mean is equal to the after treatment mean. Then we come to the chi-square test. Actually, chi-square test, this is a test which is used to find that whether there is an agreement between the theoretical result and the experimental result or not. So now this test summarizes that whether there is a difference between the object value means this is the your object value experimental result, and experimental value means this is the result in the experiment means experimental result. Whether there is any agreement between this experimental result or object or experimental result or theoretical results. When there is agreement with so now in this case, now what happened is chi-square distribution is positively skewed distribution, and it is always one-tailed distribution, and there is minimum value can be 0, but there is no limit for the upper value, and actually the number of degree of freedom, the chi-square becomes more symmetrical. Actually in this case the degree of freedom is number of degree of freedom. Now in this case, we see that this is when degree of freedom is 1, then now graph will be like that. When degree of freedom 5, like graph will be like that. When degree of freedom is then it becomes symmetrical like that. This 9. So So now actually the formula for Cascade, this is object value, object frequency of ith class minus expected value, then the square of this one divided by the expected value of ith class. Actually, this is for we have O1 minus E1 square of this divided by E1 plus O2 minus E2 square of this one divided by E2 plus like that. And actually, what happened that if the difference between the object and actually be more, then chi-square will be more. If the difference is less, then chi-square value will be less. So actually, what happened that this will indicate when the difference is very less, then we say that experimental result and the theoretical result, they are in agreement with each other. Otherwise, if the difference between the object value and the actual frequency is more is large, so then in this case we say that the theory and the experiment results, they are not in agreement with each other. Actually, the chi-square, they have various applications of chi-square. Actually, it can be used for testing of the population variance. It can use testing of the fit of data. It is testing the independence of the attribute and testing of the linkage in the backgrounds. And now this can be used for testing the humidity of population variances, and it can be used for testing the quality of the several population. Actually, chi-square test both parametric and non-parametric. Actually, this is only one test which acts as the parametric as well as non-parametric. Actually, in case of because when we are testing the population variance, because in this case we are testing population variance is the population parameter, so it will behave as a parametric test. In case this when we are testing humidity of the population variance, means in this case null will sigma 1 square equal to sigma 2 square equal like that. And then now in this case, this is because we sigma is the sigma of population variance is the population parameter. Similarly, we can in case of when we are testing the we say that as now rho 1 equal to rho 2 equal to rho 3 equal to rho 4 like that. In this case, because rho is the population coefficient is the parameter. So now in this situation, the chi-square test will behave as a parameter test. Now in these three tests, in the test you have the solution of the data that is as a non-parametric test. Now a good enough fact means that you say us to find how well does that assume distribution. Now in this case that if we have data from different distributions, then we will try to fit, and we find the difference between object and the expected frequency, and then if the difference is not is less, then we say that that data is fitting the particular distribution or not. This is the same example here. So now here we have now 60 students were divided into two class of 30. So one class used the conventional method of learning, and other class used the new experiment method. At the end of the class, each student was given a test of writing a computer program. Then the results are given this now. Method conventional, then how they are correct. 23 written correct, and 7 wrong incorrect answer. Then in case of experimental group, they are 27 right correct answer. Now in this case, we want to see whether there is a association between the method and the there is the correctness of the answer. Now we say that there is no difference between the conventional or the experimental method, and actually that there is a difference between this one. So now in this case, we can find expected frequency. Expected frequency is frequency of the ith R1 into frequency of the column 1 divided by n. So in this case, this sum will be now this sum will be 50, 30. This is 30. Now 23 plus 7 is 30. These both will be 30, 31. This 30 will be 25. Now this is the expected frequency. Then we can find value this 1.92. But now we see that the value chi-square at 5% level is at 1 0 is 3.84. But now the value has 1.92, which is the less than the table value. It means that we in this case we accept the analogy and conclude that there is no difference in the in the results of either they are doing by conventional method or they are doing by the experimental method. Then we have the F test or various substrates. Actually, in this case, this also parameter. In this case, we say that nullity that now in this case we are to find that whether the variability in the two sample is same or not. So in this case, now our nullity that sigma 1 square equals sigma 2 square means that variability in the first group is if first population is same rather than the variable the second population, and after that the variability is not the same. Then the f calculated is s1 square divided by s2 square, means that is the actually in this case these population value, these are sigma 1 square and sigma 2 square are not known to us, but we can value this we can value the estimate this is the sample variance, and this sample variance of first sample, this sample variance of second sample. We find the ratio. Actually we should always see that whatever, if s2 is more as compared to s1, then s2 will be in the numerator. If in this case, if s1 square is more, then it will be a numerator. If s2 square is more, then this will be here. Then it will follow the this will be the degree of freedom n2 minus 1, and n1 minus 1 and n2 minus 1 will be the degree of freedom. Now in this case, assert if your f calculated value is more than the tablet value, tablet value is f at n1 minus 2 comma n2 minus 2 comma at alpha means either 0.05 or 0.01. If f value is more than the this tabulatory value, then we say that then we reject the null hypothesis and accept the hypothesis. It means that the variables in the two population are not the same. But if f calculated is less than the tabulatory value at alpha level sequence, then in that case we say that there is no difference in the variable in the two population, or in other words, you can say that the two samples have been drawn from the same population in which the variability is the same. When the variable is same, then it means that they are coming from the same population. Then anisovariance. Actually, anisovariance is the procedure by which the total variation in the overall data set are separated into different non-negative components. Actually, in this case, what happens that when we have to test that more than two population means, in that case, t-test cannot be applied. In that situation, we go for ANOVA, anisovariance. Actually, when we want to test equality one sample, we go for t-test. When we have two sample, we go for invariant sample test. When we have more than two samples, so we want to test the equality of C means. So we have mu1, mu2, mu3. So in this case, epsilon will be mu1 equal to mu2 equal to mu3. So in that case, we cannot test by this that is t-test. So we go for anisovariance. Actually, anisovariance, what happens that it separates the different component of variation. Actually, it separates the total variation into different components. Now we have one-way ANOVA. Actually, one-way ANOVA means in this case, the model is that this is total observed value is the general mean effect, higher treatment effect, and error effect. So in this case, what happened that total variation is separated into variation due to total this is treatment, variation due to error. So now in this case, null hypothesis will be that effect of all the treatment is same. Mu1 equal to mu2 equal to mu3 up to mu1. And H1 will be in this case at least one pair. Two means they were from each other, or you can say that at least one pair of mean differ from each other. So now in this case, this t minus 1 and 1, this will be the degree of freedom. We find some more square root of treatment, and then this means sum of square treatment. This treatment sum of square divided by t minus 1, the degree of freedom. In case of error, and this is sum of square root of error divided by n minus. Sum of square root of error divided by this n minus t, then we find the f value. Similarly, in case of two-way ANOVA, when we have two sources of variation, we have variation due to treatment also, we have variation due to blocks also. So then in this case, total variation can be separated into three components. Variation due to treatment, variation due to application, variation due to error. Actually, what happened that we have variation due to factor A, variation due to factor B means the example vector due to the error. So now in this case, we have this is the application. We have R application. This is going to be R minus 1. We have T treatment with different minus 1 and error in case of error R minus 1 T minus 1. So we can see replicate sum of square due to replication divided by T. T is the number of treatments. Then summation of this is treatments T1 square plus T2 square is like that divided by R, number of replication minus correction factor. Then error sum of square obtained by the difference between from the total, we subtract the difference between the replication sum of square minus this is treatment sum of square. So then we find the mean square. Mean square error, mean square error due to replication. This is MSR. Or replication sum of square due to then divided by the T minus. This is the degree of freedom R minus 1. This is mean sum of square due to treatment. This is obtained by treatment sum of square divided by the T minus 1. In case of mean square error due to this one. In this error sum of square divided by the this is the degree of freedom here. Then if we want to find the F calculated, then in this case FR, this is for replication, this is mean sum of square replication divided by this one error. So now for in treatment we can mean sum square root of treatment divided mean square root of error. Actually in this case, in case of 2 ANOVA, we will have two types of hypothesis. First hypothesis will be about your replication. In this case we say that if mu1 equal to mu2 equal to mu3 equal to mu4 like that. In this case we say that all the replication is same, and alternative will be that at least one pair of replication differ from each other. And other hypothesis will be about your treatment. In this case we say that effect of all it may say it means that mu1 equal to mu2 equal to mu3 equal to mu4. Then alternative will be that at least one pair of the treatment differ from each other. Now in this case what happened that when this F value, actually now we find a tabulative value at R minus 1 and R minus 1 at this degree of freedom. If this F value at this FR is more than the F value at critical value, then we reject another hypothesis and conclude that is there is difference in the replication. If otherwise, or you can say that replication fact is significant. Otherwise, when this F value this is the critical value is less than this is capital less than the table value, then we say that there is no difference in the replication. Similarly, in case of treatment, we also find the F value at critical value at T minus 1, R minus 1 into T minus 1 degree of freedom at either 5% or at 1% of significance. In that case, when this FT value is more than the tabulative value, then we reject the null hypothesis and conclude that there is a difference in the treatments. Treatment means, or otherwise, if this FT is less than the calculable value, then in that case we accept null hypothesis and conclude that there is no difference. There is no difference in treatment, or you can say the effect of the order treatment is same. Now we have considered the basic principle of experimental design. Actually, what then we have replication. The replication treatment under consideration called replication. Actually, replication treatment means that is the replication. Actually, what the main purpose is that it reduces the experimental error and thus able to obtain a more precise estimate of the treatment effect. The most important purpose of replication is to provide an estimate of the experimental error. If we are not replicating the treatment, then we are not able to find the effect of the experimental. That is the estimate of the experimental error. Then similarly, we have randomized. Randomized means that allocation of treatment to the various plots at random is called randomized. Actually, the main purpose is that it removes the biasness by giving equal chance to every treatment to get particular experimental. Thus, it removes human bias. It provides value to the error of estimate, and it provides value to test again. It is devised to achieve the independent error in the knowledge assumption, and it makes the experiment free from the systematic interest of the environment. Then, in case of a local control, means that we divide the heterogeneous experimental into Hund's law. This is known as the local control. Actually, this is done with the help of the fertility map. One can form blocks, contiguous plots, which are actually what happens then in local control. When we want to make the block, that we are the same seed of one particular variety, they are shown in the field, and then the fertility control map is prepared, and the points which are we have the similar type of yield, they are joined, and we can actual block are formed. It is experiment, and it makes the design more efficient. It makes the tests which are of a simulation more reliable, and this is the reduction in the experimental error consequently help us to dismiss the small bigger difference in the treatment. Actually, in this case, what happened that this enables us to that when the difference between the treatment means are fine, so we can detect the difference. This is completely CRD. This is completely done by design. or this is similar here. In case of CRT, this is only design in which we are not using the principle of local control. Actually, there is no block. In this case, it is assumed that the that the experimental material, that is the homogeneous one. So now in this case, all they are homogeneous. There is no difference between the treatment experiment unit. Number of applications for each treatment is not of the same. Experiment are dependent as individual and as consideration. There are normal issues. These are also ANOVA. So now in this case, we have this similar. This is the generally in fact I treatment. Now in this case, variation to combine variation due to treatment, variation due to the error. So this is the same type of ANOVA, which are in case of one way ANOVA. So here, the same. Now what happened here? Now in this case, suppose the treatment effect comes out to be significant. It means that our that effect of all is same. It means that mu1 equal to mu2 equal to mu4 equal to mu5 like that. And also with that at least one pair of treatment differ from each other. Now what happened that when this this value comes out to be significant, means this is your ft is more than the calculated value of, at t minus 1 and n minus t degree of freedom. Then in this case, what happened that our null hypothesis will be rejected. Null hypothesis means that it will indicate that at least one pair of treatment differ from each other. Now the question is that which pair of the treatment will differ from each other. So that is obtained by we have different types of tests. This is usually the one test is your Dunkel multiple test. Other test is your the key test. Then LSD means in general. We are using the LSD. This is the critical difference test. LSD or these different test. Then and if the difference between that if mean of two treatments, so T1 T1 is mean is 12 and T2 mean is 14. So then you find the difference 14 minus 10. So critical value is 12. So difference is 4. 4 is more than that critical difference value. So we say that the difference is said to be significant. Otherwise, the difference is said to be non-significant. Now, advantage that this is very flexible and number of treatment can be used and different treatment can be used unequal number of times. Actually, there is a flexibility of design that suppose we have T1, we are the replication only 3 replication. In case of T2, we have 2 replications, and in case of T3, we have 5 replications. Replication can be used for treatment. With the sample, but there is a problem max number of degree of freedom for estimation of error. Error variance, which increases the sensitivity of the precision of experiment for small experiment. That is, X is 1 over homogeneous. Yes. That when the different types mu will be 2 and mu2 equal to mu3. That effect of the compared to the tabulative value, and we can use the critical difference test for obtaining the value of the that which pair is either T1 is different from T2, or T1 is different from T3, or T2 is different from T. To do T3. Then this is RBD. This is randomized complete block design. Now this is a method of controlling the variability in the one production by using the principle of local control. So whole experiment is divided into whole block and it is loading each block. And in this case, when control variability in the one direction, so we have variability in the treatments. So then actually so now in this case we have different sort of variation. That total variation, the total sum of square is considered into variation due to treatment, variation due to blocks, and variation due to this error. In the actual layout means that RBD is divided into different homogeneous blocks, and in each treatment block is randomly allocated, and randomization is done by the random number table. So now this is the same type of ANOVA as in case of 2 ANOVA. Similar now in this case we have to either first is about your replication, other has to be about your treatment. In case of first replication means that we can say that effect of all the replicas same, and other will be that at least one pair of replicas is different from each other. And in case of treatment, we say that effect of the all treatment same. We can say that mu1 equal to mu2 equal to mu3 equal to mu4, and other have be that at least one pair of treatment different from each other. Now, what in this result that in this case, there's if suppose in case of treatment, if this ft value, now we compare this value at t minus 1, comma r minus 1. T minus 1 degree of freedom at either 5% or at 1% level significance. In this case, what happens that if this f value comes out of significant, means that ft is more than the calculated value, then we reject another way and conclude that there is a difference in the treatment means, or you can say that effect of all the treatment is not same, or we can say at least one pair of treatment differ from each other. Now similarly here also that we can there are different multi-converter test, GMT is also multiple test, and Taki test, Newman Cool test. There are several one-training tests. There are several type of post-hoc tests or multiple computer tests are available. So generally we use either critical difference test or the DMRT or Taki. But I will say that in most of the cases we should use that. We should use the Taki test, Taki or Tuke test. That is more sensitive as compared to other tests. Actually, if there is what happened that in case of other groups, that when the number of groups or number of treatment pairs are more, then in that case the all these that is the power of test becomes less. But in case of the 2K or Taki test, the power of test remains the same, and it detects the real difference if there are so. I will say that we should always use the 2K or Taki test for multiple combination test. So the advantage of this one, this RBD increases the precision of experiment by reducing the experiment error by using a precision level control. This is flexible as number of replicas can be used for the design. But always remember that RBD is but the number of replications for each treatment should be the same. It cannot allow that different number of replication. Then amount of ownership from RBD is more compared to then, which means that RBD is more efficient as compared to CRD. Statistical is simple and easy in RBD also. But if some values are missing, then the missing plot techniques can be used for analysis of the data. Then disadvantage that this is not suitable for large number of treatment, because for according to large number of treatment in the block, we require a big size of block, which will increase the heterogeneity of the block. So what happened that the RBD is not suitable for large number of treatment. If we have large number of treatment, in that case, for accommodating the large number of treatment, we have the block size should be large, so it will increase the heterogeneity. So for the in this situation, we go for the other types of design which are known as the incomplete block design. So we have some example here that the application required to determine the effect of 3 treatments on the daily body gain of steers. Steers were weighted. Actually, in this case, we have different blocks, and we have so we can find here. Now, in this case, we have obtained sum of square root. This means sum of square root to the blocks, treatment, and error. So now in this case, in case of treatment, now this 5.14, and now in this case we have three treatments. So we say here have to be there mu1 equal to mu2 equal to mu3, and alternative will be that at least one pair of treatment differ from each other. Now in this case, now this treatment value is this is value is 5.34, and this is calculated. This is the table value 5.14. Now this is more. So it means that we reject I conclude that at least one pair of treatment differ from each other. Then we come to our latent square design. Actually, in case of RBT, in this case we have in the when the fertility gradient varies into two directions. Actually, then the RBT is not suitable. In situation we use the actually so we have this latent square design. This so there is some variability also horizontal also as well as the vertical line also. So in that case, so latent square design is used. So now main feature of this is that number of application equal to number of treatment. Number of rows, number of column, and number of treatment, they remain the same. Randomized treatment is done in such a way so that each treatment occurs only once in a row and a column. So now in this case, now this is some 5 by 5 lattice square design. Now in this case, we have 5 treatments A, B, C, D, E. Now in this case, you should see here that this treatment E is occurring only once in this row and only one time in the column also. So you can check any treatment for B is occurring only once in the row and once in the column. Similar E also, this is once in the row and once in the column. So this is the layout of the lattice square design. That now in this case, the total variation, or you can say total sum of square, this can split into variation due to rows, variation due to column, variation due to treatment, and variation due to the error effect. Now here rows we have actually in this case rows, treatment, and the column, they are the number is same. So T minus 1, T minus 3. So we can find the row sum of square, column sum of square, treatment sum of square, and the error sum of square. So then ultimately we have row sum of square divided by the error mean sum of square, column sum of square divided by the error mean sum of square, then treatment sum of square. Actually now in this case we will have different about the row effect, column effect, and treatment effect. So now in this case for treatment, then if you want to this f value, then we can compare this to T minus 1, comma T minus 1, T minus 2 degree of freedom. So in this case, if this f value comes out to 0, it means this f value is more than the tablet value. Then we say that effect of the treatment is not same. It means that at least one pair of treatment differ from each other. Now in this case, for finding the difference whether treatment pair differ from each other, then we can use the different test. I told you that either Duncan multiple test, the K2K test, or LST. This is or the CD, the same thing. So the biggest standard difference 2 multiplied by the error mean sum divided by T. This now is the number of treatments. So now advantage of this one that this is more efficient than the CRD, RVD as compared it enhances the variability in the two direction. This gives precision enough height to that reduce the standard error up to 1%. Also, in case of the LSD, the data with missing observation, we can employ missing plot technique. The disadvantage is that it is less flexible compared to RPD because number of treatment limited to number of rows and column. This is not suitable when the number of treatment is less than 5 or greater than 12. Actually, in most this LSD should be used when the number of treatment lying between 5 to 12. When some values are missing, in that case, then the LSD becomes competitive and I will not make the same result. So here we have one example here that the aim of experiment was to test the effect of 4 different supplement ABCD on the hair intake of the fertility steer. The treatment was designed as a lattice square design with 4 animals in 4 period of this one. Like now in this case, we have 4 period. These are the 4 groups, and these are 4 ABCD are the treatments. So in this case, we can find the value of now in this case rows, column, treatment as well. This error means error here. Now here in this case, we say that 4.76. This in case of treatment. This value is now here we have 4 treatment. In this nothing that mu1 equal to mu2 equal to mu3 equal to mu4. Then having that at least one pair of treatment differ from each other. So now in this case, we see that f calculated more than the tabulative this tabulative value. So we take another way and conclude that there is difference in the treatment effect, or you can say treatment means. So now here also you can see here in case of rows also, because in this case row effect is not significant because the f value is this tablet value for is 4 point something, but the effect of column is the main. Actually, there is no effect of period and effect of period there, so can do this way. This is the orthogonality. Actually, this is a proper design which ensures that different classes of effects shall be capable of direct and separation without any entanglement. Actually, what happened that in case of CRD, RBDSD, is all design. These are orthogonal design. Orthogonal design means that in this case the total that is the total sum of square that can separate into total sum of square due to replication, total sum of due to treatment, and total sum of error. Actually, there is not any intermixing of any effect. The treatment effect is not mixing with the error effect, or error effect is not mixing with the replication effect, or replication effect is not effective intermixing with the treatment effect. So this is so all these design, these general design, these are the orthogonal design. Actually non-orthogonal design, these are the incomplete block design or confounded design. In that case, what happened that in that case confounded design also we lost some of the information. So those are not orthogonal designs. Those are the non-orthogonal design. But in case of orthogonal design, that this is a property that it ensures us that different classes of effects shall be capable of direct and separate estimation, because we can separate each effect of that. Actually, from the total effect, we can separate the effect of treatment, separate the effect of blocks, we can separate the effect of columns, separate the effect of rows, like that. So we can separate. Actually, what happened that total effect is separated different of that. So thank you very much. So
Thank you so much, sir. On behalf of the organizing committee and the whole team, I would like to thank you, sir, for your elaborate lecture on the basic concepts of statistics. And let us address some queries by the participants, sir, please. Sir, one question: what is the difference between?
If some participant, what?
Sir, some queries are there in the chat box, sir. We can see them.
Chat was I can check.
Yes, sir. Sir, chat. Please open the chat box, sir. What is the difference between mean and average? Which one is better? Sir, one question by the participant is, what is the difference between mean and average? And which one is better to use in research presentation, mean or average? What is the difference?
Between mean and average, they are the same thing. They are not different.
Yes. So next question, sir. Using RBD in case of animal experiment, if one animal is sick for some time, it will carry the effect for longer period. Then how we can utilize this design more accurately?
Actually, in this case, in this case, we can use the missing plot technique. There is the missing plot technique of RBD, so we can utilize that one. The missing plot technique is there when some values are missing, so we can use that one in case of RBD also.
Okay, sir. Sir,
Hello.
One question, sir. What is the sample size in which population will be?
Missing plot technique होती है उसमें, तो उसको यूज किया जाता है.
Sir, one more question, sir. What is the sample size in which population will be always normal? Whenever we consider sample size, should we consider the size of whole population of animals in one group?
नहीं, जो नॉर्मलिटी के लिए क्या नॉर्मल ये माना जाता है ना, एक्चुअली इन जनरल तो आपका जो सैंपल साइज मोर देन 30 को हम नॉर्मली मान लेते हैं. जो भी आपका टेस्ट ऑफ एप्लीकेशन जो भी यूज करते हैं, व्हेन द सैंपल साइज मोर देन 30 देन वी से दिस इज नॉर्मल.
Okay. So the sample size should be 30. Whenever we consider sample size, should we consider size of whole population or animals in one group? Sample size. Sir, am I audible?
क्या थोड़ा क्लियर नहीं है. केस ऑफ एक्सपेरिमेंट डिजाइन ना, एक्चुअली we should have at least 12 degree of freedom. This is thumb rule that we should design the experiment in such a way so that it provides a 12 degree of freedom. At least 12 degree of freedom should be there always. Error degree of freedom should be 12. Whenever you plan some experiment, that please ensure that the error degree of freedom should be at least 12. ठीक है.
I
अभी आवाज आ रही है?
hope all the queries have been answered. Yes, sir. आवाज आ रही है, sir. Yes, sir. Sir, some participants are asking for the soft copy of your presentation, sir.
अच्छा, ठीक ठीक.
Sir, am I audible? Sir?
और क्वेश्चन है कोई?
Sir, am I audible? No,
और
questions are over, sir. Some people are asking for your soft copy, sir. Presentation soft copy.
हाँ ठीक है. आई विल नो प्रॉब्लम.
Okay.
हाँ मैं भेज दूंगा. आई विल सेंड यू.
Yes, sir. Thank you so much, sir. And I hope
thank
our
you.
participants got benefited from this presentation, and they will be applying the same in their research analysis, which is the last but the most important step of the research. Without analysis, research is nothing. So I would again congratulate you, sir, for giving us such an informative presentation in a short notice. And thank you so much, sir, from the whole organizing committee.
ठीक है. थैंक यू.
Thank you so much, sir.
ओके. थैंक यू. ठीक ठीक. ओके.
Sir, you may leave the meeting also, sir, please.
अच्छा ठीक. ओके. थैंक यू.
Okay, thank you so much, sir. Once again, sir.